Hello, Earth Science Physics of the Universe students. This is a video for week 1, day 2 slideshow and practice problems for distance and displacement. So starting here with the slides, we're going to talk about motion. And what I want you to do is take a moment to observe the movement of objects around you, the movement of the tip of your finger or a bird flying past your window. How would you describe the motion of these things? You can be looking into your house at animals, at family members, siblings, anybody who's moving around in your house. If there are bugs inside of your house, looking on TV at the motion of a character or a cartoon. You're going to describe the motion or movement of 3 things around you in terms of their speed and direction. So my daughter is running around my house. She is running very quickly and in circles around the living room. So that's speed and direction. So go ahead and pause the video and allow yourself to go to Doodle Sheet Part 1 on page 31 in your notebook. And under box 2, your response is going to be describing the motion or movement of 3 things around you in terms of their speed and direction. So now that you've done the movement around your house, we're going to talk about distance and displacement.
So let's say we have a sheep and it is hungry. So that is my sheep, my best quick drawing of a sheep, and it is just following the grass wherever it finds good grass to eat. And so in pursuit of tasty grass, it first goes 10 kilometers to the east. 10 kilometers east. And then it takes a right turn, and then it goes 5 kilometers south. 5 kilometers south. And then it takes another right turn, and it goes 10 kilometers west. 10 kilometers west. My question to you is, how far has the sheep traveled? And pause the video and see if you can figure that out. How far has that sheep traveled? All right, now let's try to answer this together. And it's a little bit of a trick question because depending how you interpret the idea how far something has traveled, there could actually be 2 valid answers here. One answer is you could say, what is the total distance traveled? So let me write this one down. This is an important concept. Distance traveled. And this would be the total length of its journey, or the total length of its path. So the distance traveled in this situation would be 10 kilometers plus 5 kilometers plus 5 kilometers plus 10 kilometers plus 10 kilometers, which would give us 25 kilometers. That would be 25 kilometers. So some of y'all might have said that the sheep traveled 25 kilometers. If that's what you came up with, what you calculated is the total distance traveled. Now some of you might have said, wait, hold on a second. The sheep was here before, and then it ends up right over here at the end of its journey. And so its change in position is it would have moved a net 5 kilometers south. From this point to this point would have been 5 kilometers south. It doesn't matter what it did along the way, what its path was. At the end of the day, it ended up 5 kilometers south of where it started out. And this would also be a valid way of saying how far it traveled. And this notion is known as displacement. So the displacement would be, in this situation, 5 kilometers south. So pause this video. What do you think is the definition or the difference between saying the distance something traveled versus its displacement? Well, as we mentioned, the distance something travels is the entire length of its journey. It's the entire path. And this thing will never be negative. You could travel 0 kilometers, but as long as your position keeps changing, this thing will only increase because it's the total length of your path. Your displacement is your change in position. And since it's a change in position, not only will we mention the 5 kilometers, we'll say in what direction. The position of the sheep has changed 5 kilometers to the south. So let me write this down. This is total length of path. Total length of path is the distance traveled, while the displacement is the change in position. Change in position.
Okay, so now you're looking at page 31, workbook doodle sheet, part 1, and box 3. And I want you to describe the difference between distance and displacement. And for the sake of that doodle box, the easiest thing to say is distance is simply how far an object moves, and it's measured in meters. And displacement is the straight line distance, or shortest distance, from the initial position to the final position, and includes direction. So you'll see there that last statement. The difference between distance and displacement is direction. And that's what should be written in box 3 of your doodle sheet on page 31. Go ahead and pause this video here if you'd like to copy that in to your workbook. So displacement is just focused on the start and to the end, not the full length it took to get from start to end. So all it matters is that I started here and I ended here, and what's the difference between those 2 points. If we focus just on the start and end points, then if you return to your starting point, your displacement is 0. So if you go running at night and you start at your house and you run 5 miles and then return to your house, your displacement is 0 because you started and ended in the same spot. But the distance you ran would be 5 miles. Now you're going to be doing practice problems in your workbook, pages 31 through 33. You will need to go back to the Tuesday slideshows and look for the video that goes through the presentation of these practice problems and gives you the answers.